Hello everyone. Today we'll talk about creating a rig for our character. The rig is a system of controls that enables us to animate a character conveniently, so that we won't need to move each element separately. Instead, we'll move elements in combination and deform the elements according to the animation idea. We'll learn to create direct and inverse kinematics, deformers, and blend shapes using which we can achieve quite interesting results. Fortunately, we already have a draft animation, based on which we'll create our 3D animation. This video provides us with all the information we need to understand what exactly we need to achieve in our project. For our rig, we'll use the object called armature. Let's create a basic scene and try to create a simple construction. To do this, I switch to the orthographic view and create armature. We already see that it's displayed in Outliner quite peculiarly. It is not displayed during rendering and features a range of additional settings and parameters that are specific only for this object type. That's why it's way easier to use this object type than curves or other element types. Armature features two modes for editing. These are the ordinary edit mode and pose mode that we'll use for our animation. Let's select the object, enable edit mode, and select the top object. If you click the E key, you will create a chain of objects which are hierarchically connected with each other. If you open the list in the outliner, you will see that each object is one of the chain elements. We call such objects children and parents based on how they relate to each other. In the pose mode, we can transform these elements by setting the necessary pose and animating. Pay attention to the fact that in the pose mode, the chain of elements in the cognominal list is available. Now let's try to create one more example. Create armature. Create an element which will deform using it. For example, a cylinder. Prolong it so it reminds us of a pipe and add several edges for deforming. Set all transform values to 0 so that all parameters in the transform section are zeroed. Now select the armature and enable the edit mode and create a few bones. Leave the edit mode, select the cylinder and the armature system, press Ctrl P to create a parent, and in this menu you can see that besides the standard modes for creating parents, there are the parameters for working with armature. Select with automatic weights. The system has automatically calculated the weights for each bone. And now select the armature and enable the pose mode to rotate the element. In this way, we have created the simplest animation. For our convenience, let's switch to the graph editor. Select the bone system, go to the edit mode, and press the I key. Set a key in the first frame on rotation. Make sure that the rotation system is in the Euler mode. Repeat the same for the second bone. Set the key in the first frame. Now we can make a simple animation, but not to make it manually, I will use a system of modifiers. Select the necessary axis, in this case it's the x-axis. I create the modifier called built-in function. It's a sort of sinusoidal wave. If you need another pattern, you can select any other option in the list. I set its amplitude to 0.5 and phase to 0.2. To ensure that it swings smoothly. Repeat the same for the top bone. Set 0.5, 0.2, and set phase offset to -1. In this way, we have created the animation of wagging. For example, for a tail. Of course, it was the simplest possible example, and in our case, we'll make a way more complex structure. But we'll move from simple to more complex work. So let's get started. Before starting our work, we need to subdivide the object into separate parts. I separated the head, the second head, the body, the tail, and I have also separated every joint of the limbs. Also, I have set the correct and convenient names for each element, and at the beginning of each name, I have added a capital letter. I have added the letter C for the objects that are in the center, L for those situated to the left, and R to those situated to the right. In this way, it will be way easier for me to control the objects when there are way more joints. Firstly, we'll make a bone system for the leg. It will be the system with inverse kinematics. To do this, I select the first joint, select a point on the hinge axis, and press Shift S. I select Cursor to Selected. In this way, I will be able to create the first armature bone exactly in the center of the joint. Create armature, enable the edit mode. For your convenience, enable the wireframe mode, and using the G key, place the bone exactly in the center of the second joint. For this purpose, I use linking. I enable the vertex mode. And now, by moving only along the axis, I set it into the necessary position. Let's make one more bone for the lower part. A bone here, a bone for the toe, and one more bone which will be used as a control. Also, add a bone for the heel. While you're still in the edit mode, select the heel bone. Holding shift pressed, select this bone too and press Ctrl P. We'll make a parent in the keep offset mode. In this way, in the pose mode, by rotating one bone, we'll rotate the system as a whole and the heel as well. In the edit mode, select the whole system and position it in the center of the leg. It isn't convenient right now because the bone is hidden in the geometry. To make it more convenient, I turn off the edit mode, go to the display mode, and select the in front checkbox to make the system always visible. Set the correct names for each of the bone elements. I select the top bone and name it L thigh. Press F2 and repeat the same with others. Let's name this bone L foot control. Let's move it. Separate this bone from the main setup by pressing Alt P and clear parent. Position it at the front base line. Or no, let's do it in a different way. In the edit mode, add one more auxiliary bone, unlink it from the main setup, and position the control bone with the links like this. Now link the bones of the heel and the foot to the control bone. In the edit mode, it will move the whole group and link this auxiliary bone to the control bone. Let's name the auxiliary bone L leg IK. Now switch to the pose mode. Select the IK bone and this bone and press Shift I to automatically create an IK system. Also, we can press Ctrl Shift C to select the necessary modifier. So press Shift Ctrl C and select the modifier Inverse Kinematics. We have created an inverse kinematics system. Now, if we select the control bone and move it, we'll see that it moves the inverse kinematics bone, which controls the whole thigh leg system. Additionally, we can move the foot by rotating. The toe is separate. To create the same system on the other side, we don't need to make it from scratch. Simply go to the edit mode, select all bones, right mouse click, and select the option Symmetrize. You see that a similar system of elements appeared and is used for controlling the second leg. If we try to move the system to different sides, we'll see that IK functions in all directions. In this case, we have a robot which consists of elements connected by hinges. That's why we don't need the knee to move in different sides. To avoid such transforms, I simply add a lock for the x-axis of the control bone on both legs. Now, when we move the leg, the bone will always move only in one direction. Now let's link the geometry to the bones. To do this, I select the geometry element. Holding shift pressed, I also select the bone system and turn on the pose mode, which enables me to select the bone, or groups of bones, which I would like to link to. In this case, I want to use an ordinary constraint mode, and to do this, I press Ctrl P and select Bone. So the thigh is linked directly to the bone. Let's do the same on the other side. Select the element, holding shift pressed, select the bone system, pose mode, select the bone, press Ctrl P, and select bone. If we move the elements now, we see that the geometry of the upper part is now parented to the bone. Work with the bottom part will be more challenging, because this part consists of several bones. Thus, we'll do it in another way. Select the leg, the bone system, and press Ctrl P. In this case, we select with automatic weights. A set of vertex groups appeared on the geometry. We don't need all of them. That's why we simply delete the bones belonging to the right part. We will not work with them at all. Let's try to move the elements and see what's going on now. We see that the foot is basically moving in all necessary rotation directions. We could leave it as it is, but I already see the first artifact, which is that the upper part does not follow the bone. It's because of the vertex groups. So let's delete all unnecessary bones, which should not take any part in controlling the geometry from the vertex groups. They are leg IK and foot control. Also, we don't need the thigh bone. So only 4 bones left. Isolate the geometry and switch to the vertex paint mode. We see that each bone affects only a part of the object. And this impact isn't correct everywhere. For example, the leg bone, which is in the upper part, does not affect the upper hinge and this rivet as much as it should have. To other bones, we apply normalize all. Paint the empty parts with the maximal value or simply color them using the paint tool. You can also apply smooth to each of the bones to ensure that the transform is smooth. Let's have a look at it now. You see that the deformation is very smooth. To see the system better, we can disable the in front mode and move the constant strain again. Also, make sure that the armature modifier is the first one on the list, and all other modifiers are applied after it is applied. Let's repeat the same on the other side. Select the leg, Shift, Bone System, enable the pose mode, Control P, with automatic weights. Select the leg and delete the unnecessary bones from the vertex groups. Delete the weights for controls. Now we have 4 bones left here. Switch to the main mode. Apply Normalize All. Sometimes the bones belonging to the limb on the other side get on the list. It's recommended to delete them. Color the necessary areas. If, while painting, any bone from the other side still interferes with the overall weight of the whole element, we can use the function limit total and limit the number of vertex groups that are used to the necessary value. In this case, it's 4. They will be the main ones. All others below in the list will be deactivated. If we go back to the element, we'll see that the parameter belonging to the left side does not affect the leg in any way. Apply smooth to each item. After you are done with painting, check the deformation of the element. Make sure that the armature is the first in the list. And now, let's make a more convenient control for our setup. First of all, switch to the edit mode Select the bones, press the M key, and move them to a hidden layer. We can do the same with these bones too. Move them to another layer. For the foot control, we make a separate geometry. For this purpose, I create the circle element, I set it into the necessary pose. I select the bone system, switch to the pose mode. I select the bone which I want to hide and substitute with the created control. In the Bones Properties tab in the viewport display, select Custom Object. Now the object has become way bigger and slightly inclined. To fix that, I simply make the object smaller and find a more suitable place for it. The object is inclined because the bones are slightly inclined downwards. That's why I select both objects and center the auxiliary bone. Now the objects are leveled. Select the object, center it to the opposite side, and repeat the same trick. Select the bone in the pose mode and select the necessary auxiliary object. For the toe bone, duplicate an already existing element. Simply adjust its shape to your needs in this case. That's why I delete the unnecessary bones. Duplicate this element to the other side. Switch to the pose mode. Select the necessary element. Repeat the same here. Now the objects are transformed in the wrong side. That's why I simply move them. Now we have the control elements for the toes. To ensure that they do not rotate in different sides, we can forbid their rotation along the unnecessary axis. To do this, select the elements, set the rotation mode to Euler, and block the Y and Z axis. Now, rotation is limited to the necessary directions. For now, we can move the necessary elements to a new collection called Temp Control, so that they don't interfere with our work. For navigation convenience, you can assign a color to each of the sides. To do this, switch to the pose mode, go to Object Data Properties, and in the Bone Groups section, create a group. Assign any color profile you like to it. For example, red. And click Assign. For example, let's make all the bones belonging to the left side red. Name this group Left. So rename the second group to Right. And select a color for it. For example, let's make this side blue. Now it's easier for us to select the necessary elements. The next step is to make a similar system for arms. To do this, I firstly make the auxiliary elements I will use as anchors for positioning the bones correctly. I simply copy the elements and move the copies aside. I delete everything except the cylinders. I apply merge at the center to define the physical center of each hinge axis. I zero the transform, even both planes. Select the central vertex of the first cylinder, apply cursor to selected, create cursor. In the edit mode, I create armature. And with linking enabled, I set it to joints axis. Now we can turn off the linking. I make the second bone. Since we'll make a similar IK system here too, let's create a control bone. Right away, move the system to the correct position. I make this object visible in front of all other elements. In the edit mode, apply clear parent. Now go to the pose mode, select the main bone, the secondary one, and press Shift I, and apply to active bone. We see that the system functions quite well. Now let's set the correct names for the elements. This is the left side. L arm. This is the bone called L forearm. And this bone is L arm control. Select all elements and in the context menu select Symmetrize. In this case, the symmetry was created relative to the pivot point. It isn't what we need. That's why I revert this action. Exit the editing mode and set 0 in location. Now the pivot point is at the coordinates origin. Go to the edit mode again, symmetrize, and now the bones are in the correct position. They are automatically named correctly. To link these objects to the geometry, we apply the very same principle. Select the first part of the arm, holding Shift pressed, select the bones, switch to the pose mode, and in this case, press Ctrl P and bone. Select this element. Shift. Select the bones. Pose mode. Ctrl P. Bone. Repeat the same with this part. Select the necessary element and bones. Ctrl P, bone, and the last element. Shift. Select the bones. Pose mode. Ctrl P, bone. Unselect the In Front checkbox, and let's have a look at the result. First of all, select the Euler mode for these bones and forbid the bones to move along the x-axis. On this side and on this side too. Let's try to see how it functions. It's perfect. We are done with the hands. When we were working on them, we accidentally created a separate armature setup for them. It isn't convenient for animating. That's why we join both setups using Ctrl J. Now they belong to the United System. Before creating the bones for the upper part of the body, let's watch the animation once again. Pay attention that the upper part features a distinct squash effect when the character is walking. We'll try to achieve such an effect in our setup. For this purpose, in the edit mode, I set a 3D cursor at the basis of the back of the pelvis. And set the position at the x-axis to 0. So it's positioned accurately at the coordinate axis. Now I press Shift A to automatically create a bone. I move it downwards. In this case, my task is to ensure that it's approximately in the center of this sphere. Now let's add a big bone for the body and the necessary controller. Apply Clear Parent to the top bone. Alt P, Clear Parent. Now it's separated. To create such an effect, we'll use the constraint Stretch. Select the controller, select the main bone, and press Ctrl-Shift-C. Select Stretch 2 in the list. Let's try to figure out how it functions. As you can see, the bone attempts to preserve its volume. When it's being stretched, it narrows. When it's being squeezed, it widens. It looks quite fascinating. Let's attach the body to the bone. Holding Shift pressed, select the body and the bones. Switch to the pose mode and select the necessary bone. Press Ctrl P and select bone. Now, when we move the controller of the back, we get the animation which is quite similar to what we have seen in the reference. Let's name the bones correctly. Further, the proper naming will significantly simplify our work. I name this one C-Spine 01. This one is C-Spine Stretch. And the top one is C-Spine CTR, which stands for controller. Now the body moves separately from the arms. To fix that, switch to the edit mode. Select the main elements of arms, that is, the upper parts and arm controllers, and parent them to this controller of the back. Ctrl P, keep offset. Let's try to move it and see the result. We can notice quite weird twitching in the animation. And what's more is that the arms don't follow the rotation of the body. That's not the result we expected. Also, if we try to move any of the arm's controllers, we'll see that the issue concerns the very setup. All that is caused by the inverse kinematics settings which we applied to the arms. Pay attention to the fact that the yellow line goes exactly to the basis of the whole hierarchy chain. So if we go to our setup, we'll see that the back controller is on the very top of the hierarchy. The inverse kinematics constraint is applied to the whole chain, including the back controller. The thing is that inverse kinematics can be applied to the chain, and sometimes it may be really useful. For example, let's make a similar setup. We see that in this way we can create complex systems of bending bones. For instance, for a tail or octopus's tentacles. But we don't need this functionality in our setup. That's why to set the necessary number of chain elements in the settings of the constraints, there is a parameter called chain length. If we set 2 in it, the inverse kinematics chain will end on the second bone. We have a similar situation here. Additionally to everything else, here there are several items with inverse kinematics, and they conflict. And that's why we get such a weird twitching. Let's bring the bone back to its initial condition. That's it. And simply set the length of the chain to 2. Correspondingly, set the same value on the other side. Now the system functions correctly without any errors or twitching. But we haven't addressed the rotation issue yet. To add the rotation, let's add one more constraint to our system. Select the back controller and apply track 2. This controller ensures that the elements are rotated in the direction of the specified object. To do this, select the armature system. In the future, we'll rename it more correctly. Enable the target Z mode. Set up to the correct up direction, that is to Z. And let's select the axis that will work best in our case. Of course. It doesn't work right now because the target bone is not selected. So let's select it, and since we know that the bone is called spine, simply enter spine and find spine 01. Now we see that it's rotated. The overall position is inherited. But for now, it's not in the direction we need. That's why we'll select the correct one in track axis. As you see, we need the inverse value for y. So this is the result we need. Now the shoulder level is preserved and we get exactly the movement we need. If necessary, for rotation, we'll use the first bone. Let's set the Euler coordinates mode for it, and by rotating this bone, we can rotate this part of the system. That's basically what we need. The only thing we still lack is the rotation of the whole system with this main axis. To do this, we'll use one more bone. Set cursor in the center and in the edit mode, create one more bone. It will be a sort of main rotation bone. Link the back controller to it and the bone spine 01. The last is the bone to which it should be linked. Keep offset. Now let's try it out. We have achieved the rotation of the whole system. tiny rotations. And if necessary, we can even make a sort of displacement, following the sphere's radius. Let's name this main bone spine 0. Select the unnecessary bones. By unnecessary, I mean those that we don't need to be displayed now. Press the M key and move them to the layer below. For the head, we'll make a similar system. In this case, I set a 3D cursor at the basis, change its position in the x-axis. I select the bone system in the edit mode, press Shift A, I create a bone and a controller. I separate them. Switch to the pose mode. Select one bone, the second one, and select Stretch 2. I make sure that the system works as I expect. Now I select the head, select the bone system, the necessary bone, Control P and bone. Now the head functions as we want it to. Let's set the correct names to the elements. Let's also make an overall controller for the head. I make it smaller and name it C-Head0. And parent two other bones to it. Keep offset. In this way, I ensure the possibility to transfer the whole group. And rotate it without any deformations or any need to select all elements. And at the same time, we have the possibility to incline it. At this point, I see no sense in attaching the head to the body. If we have a look at the animation, we'll see that it moves independently from the body, and if we attach the head to the body, it will be quite hard to eliminate the impact of the body's rotations on the head later when we will be animating, especially when all elements belong to one group. That's why they stay separate objects for now. Let's move on to the tail. Go to the edit mode, select the elements to which I want to set a 3D cursor. Using Shift A, I add a bone. We'll make several bones which will repeat the curvature of the tail. But before that, I want to add one tiny bone here. It will be a sort of pelvis, and next we just extrude the chain of bones. Let's make the last one separated from the group because we need to add the inverse kinematics here too. Select the controller, then the necessary bone, and apply inverse kinematics. Right away, set the necessary chain length. So we need it to end on this big bone. That's why I simply set the value we need. Excellent. Attach the body bone that is spine 0 to this tiny bone. It will be the main one now. Also, I need to attach the upper leg parts to it as well. Select it with shift pressed. Keep offset. Note that, like in case with the arms, we forgot to change the number of elements in chain length for inverse kinematics. That's why if we now try to animate something, we'll see quite hilarious behavior. It's pretty hard to control and manipulate such a system. For this reason, let's set the necessary chain length. After we fix the inverse kinematics, everything should move exactly as we expect it to. The only thing I have noticed is that now the leg's geometry doesn't move for some reason. The thing is that when we joined the armatures into one system, the name of this structure changed automatically. It's an extremely significant change for the modifiers. In this case, the main object was lost. The name was lost, and that's why we need to reassign the name. Now make sure that the whole structure functions flawlessly. Now we attach the tail to the bones system. But to do this, I will apply a tiny trick. I select the tail chain, and in this case, I need the chain without the controller. And I detach the selected element by pressing Alt P. In this way, I have created one more bone system. I did this to ensure that we can assign the weights for vertices not for all bones of the skeleton, but only for the tail part. That's why we select the geometry. Holding shift pressed, I select the tail bones, press Ctrl P, and apply with automatic weights. Let's check how this system functions. Pay attention that even in such an isolated condition, we face huge problems with the weights. The edges are harsh. Some elements lack weight and they are not affected by the bones. All of that looks quite poorly. That's why I suggest to follow another approach. Let's delete the modifier from the geometry. Let me find it. Armature. And for the tail geometry, we'll make an auxiliary geometry, a so-called cage. It's a simplified geometry which will outline the overall shapes. To do this, I create a circle. I set 8 vertices to it and make it bigger. The main task of this circle is to outline the overall shape. I extrude it. And using the common polygonal modeling methods, I repeat the mesh outline. The most convenient way to do it is to ensure that there's one cut per one bone. So we have a cut here. We'll have a cut here for the smallest bone. Now here, element here, and the final element. Let's adjust it so it's more similar to the necessary shape. We have created such a system. We can slightly adjust it by applying the relax command to each of the cuts. We can apply it to any part, but take into account to what extent this command deforms the object. I won't apply it here, but I will apply it to the final element. We can also close these parts. We can consider the cage to be ready. Now let's try to use this cage. To do this, we initially enable its display in the wireframe mode. Display as wire to ensure that it doesn't interfere with our work. Select the geometry and create the modifier Surface Deform. Move it so it's above the subdivision modifier, and set the cage in the target field. Apply the command bind. Now if we edit the cage, we see that we edit the whole construction. There are no issues with the weights and so on. Technically, if necessary, we can even make the subdivision modifier for the cage. But before doing that, it's worth applying the command unbind and bind once again to get the last value. The subdivision modifier didn't work, so it means that we'll proceed without it. I don't want to do it, but if we could apply it, everything would have worked. But I don't want to leave too much geometry on the very skeleton. Now we can attach the cage to the bone system, to the tail. With shift pressed, I select these elements and apply with automatic weights. Now let's check out the results. You see that now the movement is smoother and more predictable. Now if we join these two elements, these two armatures by selecting them both and pressing Ctrl J, go to the pose mode and check how it functions. You see that the tail doesn't move correctly because Cage uses the armature which doesn't exist anymore. So let's assign the right one and now try to work with it. As you see, it functions approximately like we need. The only thing is that we can slightly adjust the weights on the cage. In particular, select this bone and this top bone, and assign the maximal weight to the upper part. To achieve this, I simply quickly color these vertices. Alternatively, we can switch to the vertex mode, With Lasso, select the necessary vertices and press Shift K. It's a shortcut for set weights. See, something still conflicts, so let's check all other bones. For this bone, we can again use Shift K. We can use the smooth command to smooth the resulting values. Let's check to ensure that no other bones interfere with the upper part in any way. Apply Shift K to these points, and to the last part as well to assign the maximal weight. Let's have a look at how the tail functions now. Generally, it functions way better. Let's try to assign one more modifier to the cage. It's called Smooth Corrective. It's used to minimize the flaws of surfaces, especially when the surface is subject to significant deformation. As you see, now the surface looks way better. The last element to make is the head. It isn't the simplest element. That's why we have left it for the very end. The thing is that it consists of a big number of elements. If we have a look at the animation, we see that it features several quite specific movements. The head should be able to close the eyes and the mouth. At the same time, it significantly deforms. Of course, we won't do the fully fledged face rig for this project, because our task is to create the animation of a simpler type. Nevertheless, we need to deform the head in some way. The creation of a complex bone system and long adjustment of weights is not the method we would go for. Instead, we will do it differently. We'll create an auxiliary cage and transfer the weights from it to the final geometry. For my convenience, I will now separate the elements of the eye so it's a separate geometry. And I will also need a more detailed geometry in some places. Let me disable subdivision. More geometry, particularly on these ridges. Accordingly, I simply apply extrude for each of them like this, and I also add one more cut to each of them, so that they can deform more smoothly. Basically, that's what we need. Additionally to all that, I will probably create the auxiliary geometry for the eye, because we will make the shape deform for this area. That's why I apply subdivision and add smoothness to preserve the curved surface. One more, with smoothness again. Now, simply with the knife tool, I cut the elements I need. In this area, the accurate symmetry is not too significant. Here, we'll cover this area with pentagons. Let's create a similar topology here too. It doesn't affect the smoothing in any way, but it's easier to deform such topology. Now let's make the cage. To do this, I create a plane, move it upwards at the level of the face. Now I will create a cage. It will be a plane outlining the main elements of character. Facial elements in this case. I disable so it doesn't interfere with my work. Move it here. Keep it like that for now. Extrude. One more extrude upwards. So I will have the cage for the maxilla and the mandible. And the last extrude. It will end like this. I adjust it to match the shape of the head better. Now I add some topology here. Like this. For our convenience, we can smooth the internal part using the relax command. Let's apply it once again here. Select all of these elements and apply relax once again. We can also round this area. I will use the loop tools operator called space, so the space is the same. Relax. It seems to look better now. We can adjust it a bit more in the proportion editing mode. From the technical point of view, this cage should be enough. We have created such a construction. For our convenience, we can set its display mode to wireframe. And now we can make armature for this element. Let's see. The 3D cursor was created at the origin exactly where we need it. Create armature, and now we'll do it like this. We add a main bone, a bone that goes upwards and deforms the upper part. Also, we'll add the spade bones, which will be used for deforming the spades. We won't create too many bones here. We'll try to solve this task using the minimal necessary number of bones. We need a similar element here too. Let's disconnect this one. Let's do it like this. Let's repeat something similar on the other side. In this case, we don't need any additional bones for spades. Generally, such a deformation should be enough. Let's even the bones. We also need a bone for the maxilla and for the mandible. I won't create two bones for each jaw. This deformation should be enough in this case. And I need some more bones. Let's add one more here. One more here. Remove parent attachment. Make it shorter, approximately from here. Unparent this bone too. Let's move the bones to place them more evenly. This setup should be enough. We won't make any overly complex elements. The most important thing is that all the bones we have are parented to the root bone. Check it. For some reason, not all are parented correctly. Now all the elements move with the bone. We have these elements for the spades on the head. Above the eye, there are separate bones for jaws, and possibly a bone for our cheek and the mouth corner. Let's see how it functions. Now select the cage. Holding shift pressed, select the bone system. Press Ctrl P and parent them with automatic weights. I have it transform on the bone. Here it is. I zero it. Now let's see how the cage functions. Generally, there's a deformation. The first jaw. The second jaw. We can keep only the cage for now. Here is the mouth. Let's slightly adjust the weights. Select Weight Paint. By right mouse clicking with shift pressed, we can get the information about what bones affect the selected vertex. Now we see the bone group, and I believe that it will be inconvenient to work with the weights and such bone names, because we are likely to confuse them. That's why let's rename the bones real quick. In this case, I tried to assign the understandable names to them. This is the bone number 1 and bone number 2. Name this bone Forehead 01, and this one will be Forehead 02. This one will be Chin. This bone will be Jaw down. Correspondingly, this one will be Jaw up. And these bones are left. Let's name them correctly too. Let's call them Nape, these will be Nape up to differentiate between them. Now it will be easier to paint the vertices. Select the necessary bone. For my convenience, I go to the Tool tab and enable auto normalization of the values. I set weight to 1, and in the draw mode or in add mode, I add the affected area for this bone. Now jaw down. Let's increase the affected area for this bone in this direction with reduced weight value. Adjust. Now I want to have a look at forehead. I don't want the eye area to be too deformed. I want it to be controlled by the bone, not by bone interpolation. That's why I slightly increased the value here. Let's now try to move this area. This part is fine. The forehead works fine. One jaw and the second one works alright. The cheek is good enough. We can slightly adjust it. I see a bone with the wrong name. This is the cheekbone. Let's name it properly. Check its impact. Let's increase the area it affects. Let's probably increase the impact of the bone head 0 on the basis of the whole system. Let's check how it functions now. Yes, that's what I wanted to achieve. Yes, something like this. So we have assigned the weights. It's quite easy to paint them. Now we need to transfer the weights to the head. We'll do it using the modifier called data transfer. Select the head. Select data transfer in the list of modifiers and set the object from which we want to retrieve the information to be transferred. Accordingly, this is the plane. We didn't name it correctly, but now it doesn't really matter. Enable the vertex data checkbox to transfer the vertex paint data, that is, these weight values. As you see, no weights are now assigned to the head. That's why we open the vertex data parameter and specify vertex groups. Specify that the nearest interpolated face value should be transferred. And apply generate data layers. In the Object Data tab, we'll see that the weights are transferred with all the values. Now we need to create one more armature modifier. Move it here. In this modifier, select the head armature. Now armature 01 is selected. Now let's try to check how good it functions. Go to the editing mode and move the elements. As you see, the head is now engaged by the skeleton. These tiny and weird artifacts you see appear because we are using the values from the modifier for now. Accordingly, it will recalculate the weight's values every time we move the geometry. To bake the set values, we simply need to click Apply for this modifier. Now all of the values are correctly transferred. We have an opening mouth. Fortunately, there will be no such tremendous rotation movements in the animation. But generally, such movements are not typical of such skull kind. There are some deformations here. Also, we can control the nape from here, and we can do such things too. As you notice, there are some flawed elements, but we can fix them using one more modifier we'll apply to the head. It's called Smooth Correction. Place it right below the armature modifier. As you see, it attempts to correct all these ugly deformations. It attempts to draw the geometry as beautifully as possible. Excellent. The geometry functions well. Since there is a bone that can move back and forth, let's use it to attach the eyes to it. I select the eyes and with shift pressed, select the bones. Now select the necessary bone and apply bone. Let's try it out. Now the eyes are connected to this bone. Generally, the value here is within the allowable range. I'm quite content with it. Let's set all the parameters to the initial values. Now we need to ensure the possibility to close the eyes. To make the eyes closing, we'll use the system shape keys. Let's disable the subdivision mode because we don't need it for now. Other modifiers won't interfere with our further work. Go back to shape keys. To begin with, we'll make the first shape key. It will be the basis, the initial shape key, which will store the initial value of all vertices. Shape key 1 is the option when the eyes are closed. For this purpose, I create value 1 for it, and now I can modify the geometry using all available means. I switched to the sculpt mode, and now, using symmetry, I'll try to carefully close the eye. In such a case, you can use any brushes that are suitable for achieving the desired result. Switch to the edit mode. Hmm, why do I see a completely different result in the edit mode? It's quite weird. Let's try to disable the armature as well as all other elements. This issue is likely to be caused by a modifier. For example, smooth correction. It could have significantly influenced the geometry. So let's disable all modifiers for now. We'll work only with the geometry. Since we have already messed up here, let's simply delete this key. We have this value here. Create it once again. It's not a big deal. Let's try to create the necessary appearance. I see that on the other side it doesn't look that nice. But from the technical point of view, the animation will take place only on one side. Let's enable the topology mode. So generally, it will look like this. Let's enable subdivision to see to what extent the eye is closed. And now we can open and close the eye. At the same time, the whole bone system is intact. Let's enable armature, so it functions as it used to. I would like to adjust the eye a bit more. Let's make it like this. Let's look at it. It seems to look better now. Let's have a look to what extent corrective will impact the shape. If its impact is too noticeable, we'll change the overall value of the weights, the factor parameter. Let's have a look at it with the enabled modifiers. Even now, with all the modifiers enabled, the eye closes quite well. You see that there is a deformation on the other side. It means that we were not precise enough at some point. Or, as it sometimes happens, the symmetry mode didn't give the expected results in such situation. That's why, in order to avoid fixing the flaws on the outer side, and since I know that no animation is on the other side, in this situation, I simply create one more vertex group called side. Enable all elements for now. Select only one side relative to the axis of the vertices and assign it to the vertex group called side. Go to Shape Keys and specify the group it should be assigned to. It's likely that I didn't specify weight. Click Assign. So now the parameter applies only to one side. Generally, it's enough in this case. Now let's try to set the value of correction shape to the initial one, 0.5, which featured the most interesting and neat shapes. You can see that the eye is slightly opened. To fix it, let's try to increase the maximal value of the closed eyes to 2. Now we can increase the value of this blend shape and see what result we have achieved. There are still tremendous deformations. So let's bring it to half of its initial value. This result is quite good. Now let's join both armatures into one. It's extremely important to join the head to the body. To do this, I firstly select the body system, then holding shift pressed, I select the head system and press Ctrl J. In this way, we have created the united bone system. Here we can parent the main head bone to the pelvis bone in edit mode. Select the head bone, the pelvis bone, press Ctrl P, keep offset, check. Excellent. Let's do the same with the bone for controlling the head below. Parent it to the pelvis bone, Ctrl P, keep offset. Now we can enable the final setup. Select the bone. As you see, now the head doesn't function together with the rig. It's because in the modifier we specified armature 01. Let's set armature 02. You see that it all works perfectly. We can move the character. To move the character aside, select the armature without any editing mode and position it in the necessary place. The only issue here is that the head doesn't follow the body. It's because the head is out of the system hierarchy, armature hierarchy. That's why I selected, press Shift, armature, and attach it, but as an object. Now the system functions well. And is animated perfectly. To finalize the project, let's make the controllers for manipulating the character. So we'll make a sort of control elements which will be located outside the character and which will be convenient means for manipulating the character. We'll simply hide the auxiliary bones. To do this, switch to the ordinary view and make several shape manipulators. To begin with, I create a circle, place it in the coordinates origin. It will be one of the main elements. Now, create one more circle and in editing mode, add several more circles within each other. You can also create a plane. Let's create a cube, place it in the coordinates origin, select the upper part, delete the edges, and we get such an open construction. With fill, close the areas and remove the central polygon, and repeat the same. In this way, we have created an element only with edges. I name all elements correctly, so it's more convenient to use them. And now I will make one more shape. Just to be on the safe side, I simply make such a rectangle. We already have the elements for controlling the legs, so now let's substitute the controlling element for the tail. In the bone editing mode, in the bone settings, in the viewport parameter, I set custom object. It will be such a sphere. I can change the size of the sphere. And hide the auxiliary bones using a layer. Now all layers are displayed. I preserve only the ones I need. I select bone chain and move them to the layer below. In this way, I still have the control, while other unnecessary elements are hidden. We needed to be able to turn on the in front mode and constantly see the controls without any unnecessary elements. Now let's hide this element as well. Also, there is an element for the pelvis bone which we can use to control the whole object. I have made a control for it in the shape of a box. I increase its size and flatten it by the z-axis. We have gotten such an element. It's the head. Note that for some reason some weights are applied to this head too. Let's check it. I think that it's due to the naming. Yes, the thing is that the bones should be named slightly differently. Let's rename the chain of these bones. Make sure that the bones function as they should. Now names are correct. Everything works as expected. For the hand bones, select the appropriate shape. I use such spheres here, but I make them smaller. Zero point 0.5. And on the other side, set a similar sphere with the same size. Let's make it 0 0.6. Okay. The rotation bone for the back. Make a big sphere for controlling it. Let's visually substitute this bone with such a plane. But set 90 for this plane, and if we rotate this plane by 45 degrees, we get such a rhombus. Move it upwards and increase its size. Or no, we won't make it a rhombus. Instead, we'll set its size to be proportional to the lower body part. To do this, move the elements upwards. So now we have such a convenient element for rotating and positioning. We have a number of bones we'll need. These are the bottom head bone, the main head bone. Let's, for example, make it like this. Rotate it by 90 degrees. In this way, we'll know that it's this bone. And the upper body part will be flat as well. Rectangle. Rotate it by 90 degrees and stretch it in the necessary direction. Like this. I will move it downwards a bit so it doesn't overlap with the head bone. Excellent. Now the bottom sphere bone is left. Let's make this bone a sphere and move it upwards, and in this way, we'll ensure that it's a sphere controller. and the bottom part will be a circle. "90 degrees and set the convenient size. Now a tiny bone at the top for squeezing. Let's set such a shape for it too. Rotate it by 90 degrees and move downwards. Several more bones are left. The head bone, let's make a separate shape for it. I create a plane. I make it an oblong. And make such an outline of the head shape. I apply relax and make the space the same to ensure that the shape looks nice. Let's name this space head. And now for this bone, select the head shape. The shape is rotated, but we know that it can be fixed with the ordinary transforms. For the upper and lower jaws, I make boxes. Let's ensure that it matches the jaw's shape. I repeat the same for the lower jaw. I copy the values of its proportions from the upper jaw and find an appropriate position for it. From the technical point of view, we don't even need to make any separate shapes for these bones. We can simply convert them, or, to be more accurate, make them look as wires. We can select them anytime. Or not wires, it will be better to make them sticks. Like this. In this way, they don't interfere with our work, and at the same time, we can conveniently select them anytime. Also, the color scheme is quite important. Now they are all colored black, but we can easily change it by adding some design and fix visual features for differentiation. To do this, in the Object Data Properties of the bone system, create a new bone group. Let's name it C for center, and set a convenient color scheme you like. For example, this one. And we can also create right and left. This is the left part. Let's assign it here and color it orange. And the right part will be blue. The central part can be yellow, for example. Make a separate group for the pelvis. It will be like this. Central group for this one, and central for this one too. Let's create one more group. Let's name it deform, and let's make it green. As far as I remember, we haven't used this color yet, and the green color will be assigned to such elements. The final touch is to name the system correctly. Let's name this character Balanced Dino, or we can call it Dino Robot. At this point, we can consider the rig preparation for animation is finished. The very last thing is to make sure that all the bones are in the Euler mode. I click them through and check whether it's active for all elements. It should be done for each control bone, because the animation keys will be recorded on them. And it's necessary to make sure that transform parameters of each bone are set to 0. That's basically it, and we can proceed with the animating.